Okay, in this graph, in this lab, I'm gonna show you how to do the tangent lines for the G moving plots lab, and also how to compare those to the value in the table. You're gonna need your data table and the calculated velocities. You also need your position time graph, and really the thing to do here is to pick a time where we're gonna find a tangent line. So I'm gonna pick 4 seconds. That looks like a good place, and I'm going to draw a tangent line there. And that line looks nice and tangent. Basically, a tangent line just has the same slope as the graph at that point, right? Okay. Whoops. There we go. We had a little aberration there. Okay, so that's a tangent line at 4 seconds. Is at 4 seconds. Right, and we're going to get the slope of it from these points here. Okay, and so this point here is over 0 and up. Oh gee, look at that. Okay, I think that's up 50. Is that right in the middle there? It looks a little high. I'm going to say 51. Right, because this is 40, that's 60. It's up a little more than half. I'm going to say 51. And then it's over 0. I'm reading these off the graph. This one is up 160. That's easy, right? Right, but it's over... This is 5 and that's 6. So this is... Malone, hey. Okay, this is 5.3, I think, over, right? And then in math class, they showed you how to do the point-point form. So this is going to be rise over run. The rise for A is 160 minus 51, and the run is 5.3 minus 0. Right? So you just go y minus y divided by x minus x, right? And then you just pipe it into your pipulator. Okay. Okay, parentheses. You got to use parentheses. 160 minus 51 divided by parentheses 5.3 minus 0. And that's 20.6. And that's centimeters per second. The slope of position is velocity, right? Now, I want to compare that to at 4 seconds, right? Well, here we are at 4 seconds. It touches the graph at 4 seconds. I want to compare that to the velocity at 4 seconds. Well, there's 3.94, 4.1, right? We're just looking at the time here, right? Okay. So again, here this line touches the graph at 4 seconds. I didn't use that point to find the slope. I used the end points because that's more accurate. At 4 seconds, I look it up in the data table, right? And I write a little sentence, and the sentence looks like this. The slope of the tangent line at 4.0 seconds was 20.6 centimeters per second. This is a rather good agreement with the value of 21, which is in the data table. Yep, and we're done with one of them. So let's do another one. Let's pick, let's do an exciting one here. I kind of like this spot here. Looks like those are like all about the same. So I'm going to do that spot right there. And of course, this is going to be a little more challenging because, like, where does that actually touch the graph? I think it's like right there, right? And then where is that? Well, it's actually over here at. And sometimes you need to draw a little line, right? What is that? That's 2.3 probably. Yeah. I'm going to say this is slope B at 2.3 seconds. Yeah. And then I can read these points. Read the endpoints. I'm not going to use that point right there, right? So this is about 0.7 over 0.75. What is that? There's 0.5, 0.75. Yeah. 0.75 over and 0 up. right? We're here on the 0, right on the x-axis, right? So 0.75, 0 up. This one is, this point here is, what is that, 4.1 maybe? Yeah, it could be. 4.1 over, and it's easy, it's 160 up, right? Yeah? And now I can find the slope of B. Here's A. Here, let's find the slope of B. And that's the rise over the run, right? So 160 minus 0. It rose all 160, right? And the run is 4.1 minus 0.75. Right? And now I'm going to put that in the calculator. 160 minus 0 divided by, and then I got to put the denominator in parentheses. So 4.1 minus 0.75. There we go. And that's 47.8. And that's centimeters per second. And then that is at 2.3 seconds, I think is what we decided, right? It's about 2.3. Right? So again, we've got to compare that, right? So where's 2.3 seconds? Let's find it here. Here's 2.3. Yeah? Okay. And then that was 47.8. So the slope of the tangent line at this point was 47.8 centimeters per second. The value here seems to be 50 consistently. This is a little bit off, but still pretty close. Or you could subtract those and say that it's 2.2 or something like that, right? I hope that helps.